All right, welcome everyone to our Acids and Base Lab, which you may know as I shot in my dining room the other day, and I had help from my children. You'll see my third on there, Jude Nicholas, helping us out. And so what we're doing today is we are adding several household chemicals to a couple of indicators and trying to get a sense as to their pH based on the color of those solutions. And so we're going to be using both red cabbage and universal indicator as we look at these household items. So make sure that you read through the background information and look at the data sheet before you watch the rest of this video. And so we're going to spend most of our time adding everything to red cabbage, because red cabbage juice has several ranges. So we have things that turn mostly red and kind of the strongly acidic, kind of pinkish and purplish is kind of slightly acidic. Blue is kind of slightly basic, and if you get a green or a yellow color, you have something strongly basic. And so what I've done is I've taken red cabbage leaves, added them to a beaker with some water, and then heated that. You can see the steam still coming off of that until I get this nice pretty purple color. Again, I'm using deionized water here that's purified. And so we're going to take that solution and we're going to add it to a bottle, and then we're going to add that to the different household substances that I went around the store picking up that were virtually colorless. So we're going to start with lime juice, and this is the first one that we did. And so what you're going to see here is we realize that we're going to have to dilute some of these down with some water to give us enough of a solution to deal with. And there's my 8-year-old Jude helping us out, adding some drops of red cabbage juice. And what we realized is that it's going to take, a few milliliters to really see the color change. And so after he got done stirring here, we realized that we needed to add more to really see that color. And so we stopped recording, added enough, and kind of decided how much we're going to take. And you can see once we've added enough, that lime juice forms something that's kind of pinkish in color, not quite red. Next, we went with baking soda, and here we have that solid baking soda in a beaker. So I'm adding water to give ourselves a mixture we can add our cabbage indicator to. And so Jude's going to stir that up for us, give us a little bit more of a homogeneous mixture. And now he's going to add in our red cabbage juice. And what you see is we get kind of a bluish color. Not quite green. And so it's more in that kind of 8 to 10 range on that red cabbage scale. Now, the next substance we did was some Right Guard, this gel deodorant. And so we squeezed out some. I took a knife and scraped it into a beaker. At that point, we realized that we're going to need to add some water to try to make a mixture. It's not super water soluble, but we were able to get enough dissolved, I think, so that we can tell the pH of our deodorant. Jude's mixing it up as best he can. Again, it's a little bit of a gelatinous substance. And so once we've mixed it up as good as we can, and I went in there myself and did a little bit more mixing, Jude's going to go ahead and add in some indicator. And what you're going to see is not much of a color change, which makes sense, right? Things that you're going to put directly on your skin like that probably don't want them to be strongly acidic or basic. So we're not going to see much of a color change there with our deodorant. Now, here's Sprite, one of the colorless carbonated beverages we could find. No need to dilute it, so we're just going to add the red cabbage juice directly to our Sprite here. And when that happens, what you're going to see is that, like most sodas, there is an acidic nature to them. And you can see that Sprite has kind of I would say a pinkish red color. It's a little bit more pink than red, and we'll see some things that are a little darker red as we work our way through. Next up is nail polish remover, and this is an acetone-based nail polish remover. It's already a solution, so no need to dilute it. Same thing as with our Sprite, so we're just adding our indicator directly to it. And what you're going to see is that, again, not much of a color change here. Maybe slightly less purple, but really not much at all. Next up we have aspirin, which come in pill form, of course, and so I've taken some of those and smashed them up. Now we're adding some water to make a mixture of our aspirin. Aspirin is made up of something called salicylic acid as its key ingredient. And so once we make our solution, when we add our cabbage indicator, what you're going to see is that we get something that's quite on, kind of on that red side, down in that dark pink reddish sort of area. Next up we have this sparkling apple drink that they had on clearance, so we're going to add some indicator to that. Was not very good, by the way. I tasted it afterwards. But you are going to see that it is down there in the acidic range. So we get that reddish color. Next up we have drain opener. This is a gel form, so I'm adding some water to kind of loosen it up. It was quite viscous. And so as Jude kind of stirs that up carefully to kind of create a mixture, we're going to add our indicator. And this is a situation where we're going to end up with something that has gone beyond blue, right? It's more in that, it's definitely at least green, almost greenish type yellow. So now we're looking at something that is close to the edge of the alkaline range that our red cabbage juice can indicate. Once you hit 12 and 3, the color doesn't change anymore. Next up we have hand soap, and so it was quite viscous as well, so I'm adding a little bit of water to kind of create a solution that's a little less viscous that we can get the indicator to be distributed through. So Jude's going in there and mixing it. He's now going to add the cabbage indicator, and what we're going to see is that there's not much color change, right? He was expecting one, so that's why he kind of took a double take looking at me to see if he needed to add more. And again, kind of like the deodorant, right? These type of products that go directly onto your skin tend not to be super acidic or basic. Next we have a tub and shower cleaner, which is already a solution, so no need to dilute it. It was mostly water, so we're adding our cabbage indicator to it, and you can see that this is quite red. It's one of the more acidic things that we tested. And again, if you look at the ingredients on that and think about what it does, it makes sense. Next up we have some smart water, and this is alkaline smart water that supposedly has a pH of around 9, so we're going to test that out. And so when we add our red cabbage juice, we do get a bluish color that indicates that it's in that moderately alkaline pH range. Next up we have ammonia, which also is a solution, so no need to dilute. So we're going to be able to add our red cabbage indicator directly to it. And when we do, again, we get something in that kind of greenish, almost yellowish range. So definitely a pH, in that 11 to 12 sort of range that we consider strongly alkaline. And then finally we have vinegar, which is also a solution, so no need to dilute. And let's add our indicator, and we see something that is down in that reddish range that we would expect from something like acetic acid. And so what we did is we lined up all the things that we've tested. So this will give you a chance to re-look at your observations. And so, vinegar, the apple drink, the works, definitely reddish. I would say the aspirin, the lime juice, the Sprite, more in the pinkish range. We have the purple range with the acetone and the hand soap. And then, of course, we have the blue range with the baking soda, the smart water. And then we have the yellow and green with our ammonia and our drain opener. And so you can kind of redo your observations. And one of the things that we then did is took out 5 of the things kind of in the middle and looked at those with universal indicator, which has distinct colors based on different pHs within the 4 to 10 range. And so we looked at lime juice, our deodorant, our hand soap, our smart water, our baking soda, and what we found is that the lime juice has a pH around probably 5, the deodorant around 6, the hand soap stayed green at 7, and then we had the smart water, which did show up there with that bluish color right around 9, like it said on the package. And finally, our baking soda was up there in that 10 range. And so we can utilize that to then answer our question. So record your observations and then think about the questions, and don't forget to fill out your Canvas quiz.